Around the year 2000, the internet began to harden, shifting toward an extraction model that treated human beings as data points to be harvested. Timothy Charles Holborn rejected this reliance on silicon-centric models. To build a better network, he moved away from traditional server logic to study behavioral science. He found his architectural blueprint in the work of his relative, Sir John Carew Eccles, who mapped the exact mechanisms of the human synapse. Eccles proved a concept known as doomless interactionism. He argued that the mind possesses independent agency and that the physical brain serves as its supplementary machinery. In this view, the human is the operator, not the machine. If you map the brain, there's no central processor. Eccles proved it operates via chemical synapses, crossing gaps between independent nodes. Holborn realized digital storage must reflect this. Human data cannot be trapped in silos. It must flow through a dynamic, relational web. To protect human free will online, digital architecture must mimic this biological blueprint. Technology should remain the supplementary machinery of the mind, ensuring the individual remains the root of the system. By 2012, Holborn took this biological mandate to the World Wide Web Consortium, or W3C. He worked in community groups to build these into royalty-free, open standards for the web. These groups established foundational building blocks for a new web of data. They developed WebID, the read-write web, and early frameworks for web payments. To make this system sovereign, they introduced verifiable credentials and decentralized identifiers, or DIDs. These tools addressed non-HTTP URIs, allowing people to hold structured linked data outside of traditional servers. Holborn used these tools to create active computational vaults. These function as plug-and-play cartridges operating across a federated, socially aware personal cloud. Instead of handing data over to a company, these vaults pull distinct encrypted claims from external nodes. They utilize verifiable claims instruments within complex query structures to evaluate facts dynamically. Holborn called this an n-dimensional computational geometry. It creates a sovereign relational ecosystem that bypasses the rigid data capture of the modern web. While these web standards were structurally neutral, corporate actors sought to hijack them for Web 2.0 commercial extraction. Holborn had designed his computational vaults as peace infrastructure. The goal was to build digital resilience and protect individuals from administrative violence. He engineered this system to act as the inalienable extension of the self. The architecture serves as a cryptographic shield, ensuring individual choice is built into the protocol itself. The philosophical divide came down to one principle. Systems must be built so natural persons can have things, but are never treated as things themselves. Only after finishing the architecture did Holborn realize his code mirrored his own ancestral history. He had translated his family's survival protocols into the foundational code of the web. His surname traces back to the buffer zone of High Holborn in London. For centuries, this geography served as a cryptographic shield, a zone operating outside the centralized ledger of the City of London. On his mother's side, the Carew lineage traces back to the stone walls of Carew Castle. They were marcher lords who established physical frontier resilience and decentralized logistics across volatile territories. These ancient buffer zones attracted trust networks like the Knights Templar. Long before digital encryption, the Templars used complex chirographs and encrypted ledgers to secure holdings across hostile borders. Holborn had instinctively used these analog survival tactics to design the modern web of data. Holborn forged this architecture through his own survival of exploitation, health struggles, and homelessness. This creates a gap known as untransferability. When corporate entities attempt to deploy these open standards, they often reduce the complex code down to simple, flat authentication tools. But without the relational logic born from actual survival, these commercial models become rigid. Because these derivatives lack that lived humanity, they become hollow. They can verify a record, but they lack the capacity to map the common sense needed to protect genuine human agency. True technological solutions for protecting human agency cannot be stolen. They are inextricably bound to the lived experience and inalienable dignity of the natural person.